Okay, so we were talking about stress and strength. ठीक है जी? And we already talked about it much. So what I would say is that strength is an inherent property of a material. ठीक है जी? And again, it depends on how the material is made. Uh, so it depends on the processing and the constituents of that material. It is just a property of that material. Stress, otherwise, is a state property at a specific point within a body, and primarily it is a function of load and geometry. ठीक है जी? तो load or geometry जो है, because stress is equal to, let's say generally we would define stress as F by A. ठीक है जी? So F is load and A is the geometry, where is the area, um, um, the area on which that load is acting per. ठीक है जी? तो it is the load per unit area. Sometimes also a function of temperature and processing. Okay. So sometimes yes, it would depend on that. जब हम when we are designing, we need both of these, because when we are designing a component, we keep into account its strength, and we also keep into account its the stresses that are acting on that body, so that we can compare these two, and especially we can compare the stress with whatever material we choose um, for the design, so that that has enough strength to cope with the stresses that are acting on that body. ठीक है जी? We also would, ठीक है जी? अच्छा, एक बात है कि when we are talking about the strength of a material, there are many uncertainties in the strength there are some, well, I would say some uncertainties in the strength of uh, some uncertainties in the strength of a material. ठीक है जी? And that is um, that there are some uncertainties. For example, the composition of a material, right? Variation in properties of material. There are, there might be some processes that are happening nearby. The effect of those, ठीक है जी, on the properties of a material. Again, वही बात जो आप लोग कह रहे थे कि validity of mathematical models used in representing the reality. अभी हमने इस पे काफ़ी सारा बहस किया कि how do you know that exactly your mathematical model is representing the reality? ठीक है जी? So we do make sure of that, but sometimes we have to simplify things, and we have to make assumptions. ठीक है जी? Though assumptions are those things that you take for granted, and they do make sense. You will not make assumptions that do not make sense. You cannot call a straight line a circle, or a circle a straight line. But you can call a circle with infinite diameter a straight line. ठीक है जी? That will be. So there are some assumptions, and in order to cope with these uncertainties that we that we have, what we would need to do is that we would introduce something in our design that should cope with this. और उसके लिए हमने डिस्कस किया था कि we need to have well, there is a factor that we use, and we call that the design factor, ND, which is mathematically equal to loss of function parameter over maximum allowable parameter. So for example, if the parameter is load, then ND will be equal to loss of function load over maximum allowable load, which is expressed in this equation. Okay. We would also we also did an example in which there was uncertainty about the maximum load on structure and the load causing failure. There was also uncertainty in that, which was about 20% and plus minus 20% and plus minus 15%. You can take away this uncertainty by calculating the design factor. So the design factor turns out to be 1.4, and then using the same design factor, you threw away the uncertainties. By using the design factor, your maximum allowable load reduces to 7.1 instead of the nominally used load, which is 10 kilonewton. Okay. In this design factor, we also, there is a factor of safety that you already knew about, and the formula for the factor of safety and the design factor is the same. And mathematically, they should be the same. The only difference between the factor of safety and the design factor is that we start with the design factor, or फिर हम if when we are doing calculations, in the calculations we might be rounding things. For example, let's say you are performing a calculation and the diameter of a shaft comes out to be 1.67 inches. Okay. So this 1.67 inches, what do you do with this? These are Vasiko. You round it, kana? You round it to what? 1.7. So we rounded it to 1.7. And if you recall, we also said that maybe this 1.7 inches diameter is not available bulk in standard sizes. So what would we do? We would go further, and let's say that the next available, जैसे अभी हमने कहा in table A17 there are preferred sizes. Maybe let's just assume that 1.7 is not available. The only available diameter is 1.8 after this. Okay, so we would use 1.8. Now, since in our design we are using a diameter which was calculated as 1.67, but we are using a different diameter, so it is going to reduce the stress on the component. Since the area is more now, as stress is a function of load and geometry, we have altered the geometry. And this alteration in the geometry or modification in the geometry would serve that is in such a way that it will enhance the design factor. Or जब आखिर में, at the end, when we calculate the design factor, that is known as factor of safety. It enhances the safety. Okay? So we started with design factor, but we ended up with the factor of safety when we rounded things, when we used standard sizes and so on. ठीक है जी? Is it clear? Are you clear about design factor and factor of safety?
सर लास्ट में समझ नहीं आया सर लास्ट.
अच्छा, तो चले हम इस एग्जांपल को जरा देखते हैं. ठीक है जी? You would probably understand from this. देखिए, let's say that we have a shaft or let's say that we have a solid circular rod to make. ठीक है जी? और वो solid circular rod जो है हमने बनाना है with a design using a material that has 170 MPa strength. ठीक है जी? तो strength क्या है? That is 170 MPa. ठीक है जी? A design factor of 2.5. तो we also have a design factor. ठीक है जी? इसकी भी वैल्यू दी है. The minimum diameter of, find the minimum diameter of the rod. So you have to determine this. अच्छा, we already know कि stress जो है that is equal to 16 m over pi d cube के बराबर है. And we also know that our ND जो है ND is equal to क्या? S over sigma. That's देंगे ना? ठीक है जी? S over sigma. So we can equate these two, you know, and because यहाँ पे हम इसकी वैल्यू लगा देते हैं. तो what do we have? कि हमारे पास the only unknown is diameter D. So we can go ahead and find this D, and that comes out to be क्या? 0. That comes out to be 221.11 millimeter. This is the minimum diameter that we should have with a design factor of 2.5. ठीक है जी? Now, but when we look at standard sizes, so in standard size we do not have 21.11. ठीक है जी? So what do? We go for the next higher size, and that next higher size instead, because we already stated in order to reduce the cost you have to use standard sizes. ठीक है जी? और फर्ज करें ये वैल्यू 21.8 हमारे पास आती, 89 हमारे पास आती, तो हम इसको राउंड करते 21.9 पे. ठीक है जी? That is also a chance. ठीक है जी? Anyways, what we are going to do is instead of 21.11, we will use the value 22 for the diameter of the shaft that we calculated. If we recalculate this design factor, it is going to enhance from 2.5 to some other value because we used a larger diameter, and that comes out to be 3.55. So इसको फिर हम design factor नहीं कहेंगे, but we will rather call this the factor of safety. ठीक है जी? So what is factor of safety? Factor of safety is the overall design factor. अब समझ आ गई? The person who asked question, did you understand now the difference between design factor and factor of safety?
यस सर समझ आएगा सर.
समझ आ गई? Okay. अच्छा, so now going further, should we take a break? खत्म को बस है.